Hello students, welcome back to the math class. Today we are going to discuss the chapter construction. In earlier chapters, the diagrams which were necessary to prove a theorem or solving exercises were not necessarily precise. They were drawn only to give you a feeling for the situation and as an aid for proper reasoning. However, sometimes one needs an accurate figure. For example, to draw a map of a building to be constructed, to design tools and various parts of a machine, to draw roads, maps, etc. To draw such figures, some basic geometrical instruments are needed. You must be having a geometry box which contains the following. Which are those? A graduated scale on one side, of which centimeters and millimeters are marked off, and on the other side inches and their parts are marked off. A pair of set squares, one with angles 90 degree, 60 degree and 30 degree, and other with angles 90 degree, 45 degree and 45 degree. A pair of dividers or a divider with adjustments, a pair of compasses or a compass with provision of fitting a pencil at one end, a protractor. I hope you all know why all these instruments are required. Basically, to draw a line or to construct a line, we need a scale, and it is also used for measurement. That's why it is graduated with one side centimeters and millimeters and other side are marked with inches. So we can use them as per our requirement. A pair of compass is basically used to construct the different kind of angles. So we need all these instruments to draw geometrical figures. Okay, students, basically we need a graduated scale and a protractor where we need to measure. Okay, protractor is used to measure the angles and a graduated scale is used to measure the length. So basically when we require to construct or measure any kind of polygons, okay, just like your triangle, your rectangle, square or any kind of quadrilateral, okay. So these instruments are used to measure the length of the sides and the angles included, okay. So now we will discuss more about these concepts. In class 6, you have learned how to construct a circle, the perpendicular bisector of a line segment, angles of 30 degree, 45 degree, 60 degree, 90 degree and 120 degree, and the bisector of a given angle without giving any justification for these constructions. In this section, we will construct some of these with reasoning behind why these constructions are valid. Fine. So, as per your book, construction 11.1, it says to construct the bisector of a given angle. So let us just construct the bisector of a given angle and then we will move forward. Fine. So to construct the bisector of a given angle, first we need to construct an angle. Students, as it is given in your book, there is an angle ABC and we want to construct its bisector. So what are the steps? Taking B as center and any radius, draw an arc to intersect the rays BA and BC, say at E and D respectively. Okay, that means we need to bisect the angle ABC, for which we need to construct the angle ABC first. So let us just construct the angle. So students, the first step, let us take B as center and any radius. We need to draw an arc to intersect rays BA and BC at E and D respectively. So how can we take the radius? We can take the radius with the compass. Let me take the radius. The length of the radius is the distance between these 2 points, the point of the compass and the pen. So this is the radius. It is of any length because there is no radius given, so we can take any length of the radius. Now I need to put the point of the compass at B because I need to draw the arc of a circle. So let us do it. Putting point of the compass at point B, I am drawing an arc of the radius. Fine. So if I continue drawing the arc, it will be a circle. Fine. So now I have constructed an arc of a radius which is the length between these two points. Now as per your book, the point of intersection of the arc with BA and BC are E and D. Okay. Now next, taking D and E as centers and with the radius more than half DE. D and E as center and the radius more than half D. That means this is DE and we need to adjust our compass so that when we take point D, the length should be more than D, just like this. This is approximately the center, so we need to just go ahead a bit so that it will be more than DE. So we need to construct two arcs and we need to find the intersection point of the arcs. So let us do it. So I am taking the length, that is about more than half DE. I am putting the point of the compass at D and drawing an arc. Same way we have to do from point E. See students, I have drawn two arcs from D and from E and they are intersecting each other at a point. Let us take that point as F. So when I draw a line which goes through F, it will be the bisector of angle ABC. So let us draw the line. Now we have constructed the bisector of angle ABC. Fine. So what next? Now we have constructed the ray which is the bisector of angle ABC. This ray BF is the required bisector. Okay, let us see how this method gives us the required angle bisector. Fine. Now let us join DF and EF. So I have joined DF and EF. Now we have two triangles. Can you find it? BEF and BDF. We have two triangles. So in triangle BEF and triangle BDF, what we have found? BE is equal to BD. BE is equal to BD. Why? BE is equal to BD because these points lie on the same arc and they are the radii of the arc DE. So they are actually the radii of the same arc. Okay. Fine. Again, EF is equal to DF. EF is equal to DF. Why? Because arcs of equal radii. They are arcs of equal radii. Then BF is equal to BF. That is your common. So from this, what we have found that in these two triangles we have three equal corresponding sides. Therefore, triangle BEF is congruent to triangle BDF. By which rule? I hope you all get it, isn't it? It is side, side, side by SSS congruency. Fine. So, as these two triangles are congruent to each other, that means angle EBF is equal to angle DBF, corresponding parts of the congruent triangles. As they are equal, that means BF is bisecting angle ABD, because angle EBF is equal to angle DBF, that means BF is bisecting angle ABC. Okay, hope you have understood this concept. So students, let us discuss another construction. It is construction 11.2 as per your book. To construct the perpendicular bisector of a given line segment. What does it mean by the perpendicular bisector? That means a perpendicular line that bisects another line or a given line. That means it is dividing the given line into two equal parts. Okay. So as per your book, the line given is AB. Okay. The line segment AB, and we need to bisect it. Fine. So let us do it. Let me draw the line segment AB. Okay. So there is a line segment AB. Now how to bisect this line segment? Okay. That means we need to draw a perpendicular line which will intersect AB in a point which will divide AB into two equal parts. So let us see the construction part. Fine. So what are the steps? Taking A and B as centers and radius more than half AB, draw arcs on both sides of the line segment AB. That means we need to take A and B, okay, as two different points of two different circles, and we need to take the radius of the arc that should be more than half of AB. So when I put my point of the compass on A and spread it like this, the measurement should be, so this is the radius, actually this is the length of the radius, it should be more than half of AB. So I think this is more than half of AB. Now I need to draw arc on both sides of the line segment. Same way I have to do it from point B. Fine. So the two arcs on both sides of AB, they are intersecting each other at two different points. Fine. So let us draw the perpendicular line. When I join the points, I will have a perpendicular line, and that line is intersecting AB at a point. Let us give this point as point M. Okay, and these 2 points or the point of intersection of the arcs are suppose P and Q. Fine. So PQ, okay, PQ is bisecting AB at point M. Okay, PQ is bisecting AB at point M. Now PMQ, this PMQ is the required perpendicular bisector of AB. Fine. So let us see how this method gives us the perpendicular bisector of AB. Join AB, okay, to both P and Q. Fine. So I have joined point A and point B to point P and point Q. Now you can clearly see that we have two triangles PAQ and PBQ. PAQ and PBQ. Okay. So in triangles PAQ and PBQ, let us find whether they are congruent or not. If they are congruent, then we can find out some required data. So in triangle PAQ and PBQ, AP is equal to BP, AP is equal to BP. Why? Arcs of equal radii. AP is equal to BP. They are arcs of equal radii. Then AQ is equal to BQ. They are also arcs of equal radii. What else? PQ is equal to PQ. PQ is equal to PQ, it is common. Fine. Now we have got three corresponding sides of two different triangles PAQ and PBQ which are equal to each other. Therefore, triangle PAQ is congruent to triangle PBQ. As triangle PAQ is equal to triangle PBQ, PAQ is congruent to PBQ. Fine. Now, what else? Angle APM, angle APM and angle BPM, BPM. They are the corresponding angles, isn't it? So angle APM and angle BPM, they are corresponding. So angle APM is equal to angle BPM. Why? Corresponding parts of the congruent triangle. Fine. Now in triangles PMA and PMB. Fine. This is over for PAQ and PBQ, from which we got that angle APM is equal to angle BPM because of CPCT, they are corresponding part of the congruent triangles. Now let us concentrate on triangles PMA and PMB. In triangle PMA and triangle PMB, here your AP is equal to BP, AP is equal to BP. Why? They are equal radii, arc of equal radii. Fine. Then PM is equal to PM, PM is equal to PM because common side. Fine. Then angle APM is equal to angle BPM. It is already proved. Fine. So, therefore, triangle PMA is congruent to triangle PMB. By which rule? It is SAS, isn't it? Side, angle, side. Fine. So, as these triangles are congruent to each other, now we can say that AM is equal to BM and angle PMA is equal to angle PMB. Why? They are also corresponding parts of the congruent triangles. Okay. Now, as angle PMA plus angle PMB is equal to 180 degree, PMA, PMB, okay, angle PMA plus angle PMB is equal to 180 degree. Why? They are linear pair, a pair of angles on a straight angle. AMB is a straight angle and PM is creating two angles PMA and PMB. That's why PMA and PMB are linear pair. So, their sum is 180 degree. Okay. So, now we get angle PMA is equal to angle PMB is equal to 90 degree. Fine. That is PMQ is the perpendicular bisector of AB. Which is PMQ is the perpendicular bisector of AB. Why perpendicular bisector? Because now these two angles, they are 90 degree each. That means PMQ is perpendicular to AB. Fine. So, PMQ divides AB in two equal parts at point M. Hope you have understood this concept. So, students, let us discuss the next construction, that is to construct an angle of 60 degree at the initial point of a given ray. So, as given in your book, there is a ray AB with initial point A. We want to construct a ray AC such that angle CAB is equal to 60 degree. Okay. So, let us do the construction part. First of all, we need to construct the ray AB as it is given in your book. Students, let us now construct an arc keeping the point of the compass at point A. The arc is going to intersect the ray AB. Fine. So, this is the arc. Now, it has intersected ray AB. I am giving the point of intersection as D. The name of the point is D as it is given in your book. Now, we have to intersect the arc from point D as well without changing the radius. We have got another point of intersection. Now, we need to join that point of intersection with the point A. When we join the point of intersection with point A with a ray that goes towards C, we have created an angle CAB which has the value of 60 degree. Let us now name the point of intersection of ray AC with the arc as E. And now let us join point E and point D. Fine. So what we can find that AE is equal to AD is equal to DE. This is by construction. This is by construction. So, as you can see that there is a triangle AED in which AE is equal to AD is equal to D. That means triangle AED is an equilateral triangle. And we know from the properties of triangle that each angle of an equilateral triangle is of 60 degree. So, angle EAD is equal to 60 degree. Why? Because each angle of an equilateral triangle is equal to 60 degree. Fine. That means by following the procedure, we have constructed the angle CAB which is equal to 60 degree, and we have proved it by doing a construction or by joining the point ED and constructing triangle AED and finding out that AED is an equilateral triangle. That means angle EAD is equal to 60 degree, which says angle CAB is equal to 60 degree. Hope you have clearly understood this concept. Okay. So students, today we have discussed some of the concepts of the chapter construction. We have constructed some of the angles and we have justified our constructions. In our next class, we will discuss some more concepts about the chapter. Till then, keep practicing and revise well, because it is a very important chapter and you need a lot of practice for that. Keep practicing and keep smiling. Thank you.